this talk will try to understand what does it mean to scale and what questions we need to ask ourselves to define the right architecture that will fit our needs and will bring us to this right architecture that will be scalable. So we'll start from, if you are not familiar, what are we doing at Wix? We are building a platform for managing small and medium businesses, and we are trying to build a platform for answer all the online needs of a small business. We're starting from creating a website, and also you can add other services such as payments, issue invoices, or even create your logo, your business logo. In addition, we have a mobile application, and with this application our users can manage their website on the go. And also users that don't need a website can use Wix services. For example, you have a store, you really don't need a website, but you still want to use Wix payment services and to take money from credit card from your customers. So you can do this with this application. In addition, users of our users can use this application to communicate with their businesses. For example, if you are training in some yoga club or something, and this club is using Wix, you as a customer of this club can use the application to communicate with that business. Few words about myself. My name is Lev. I'm a mobile developer at Wix for the last 2 years. My background is Android, mostly Android, but today I'm an Android React-Native developer. So let's start. Let's try to define what is a scalable application. What is a scalable mobile application? I summarized this in one sentence. It's the ability to grow without compromising on the development velocity, and also in being able to increase development velocity without compromising on the quality of the application. Let's try to understand what the words in bold, what is the meaning behind them. To grow, meaning to be able to recruit and onboard people to your project, and also create more and more features. This is a growing product. And we want to be able to do this without compromising on the development velocity. Development velocity is development experience, is how fast you develop your code, how quick you ship your code to the production, and how quick you respond to bugs and users' feedback and ship fixes again to the production. And you want to be able to increase the development velocity without compromising on the quality. The quality is, of course, performance, but also functionality, usability. The users have to know how to use your application, and you don't want to compromise on this. So, yeah, it's working. Yeah. So let's go over the points that we want to cover when we are thinking about architecture, about the architecture that will bring us to the scalable application. So first of all, we need to pick the right framework to work with. If it's native, are we going to write it in Kotlin, in Flutter, in React Native? Who knows? Next, we need to choose the right architecture for our application. Next, we want to decide on the right process, on the right development process, and also on the right deployment process, so it will be scalable, meaning so the development velocity will increase. And just a second. And so all the bullets above will work. We need the right infrastructure to support our architecture. So we'll go now through Wix story and understand what was the ideas behind our decisions. So we will start from the framework. framework. So we need to pick the right framework. Looking on the classic native development, a company that wants to develop a good product and target the three most common platforms, iOS, Android, and web, need to maintain three different teams. Android team with Android people that knows Java, know Kotlin, Gradle, stuff that Android people know. iOS team with experts in Objective-C, Swift, CocoaPods, iOS SDK, and JavaScript people that know how to write JavaScript, understand HTML, understand browsers. And the problem in this model that there is two major problems. First of all these people implement the same functionality, the same business logic, but we cannot share the code between them because it's different realms and it will not work. And the second problem, that we cannot share resources, meaning we cannot take an Android developer and decide that he will write a good web application. It's very, very rarely that a good Android developer is also a good iOS developer. Maybe he can write iOS, but it will not be good. So what companies are doing now, and most of the companies, they compromise. They can compromise on productivity and really maintain three teams. And actually, this is what Facebook did and currently doing. But around 2 years ago, they understood that it's not scalable. So they decided to focus on React Native. They can compromise on one of the application. And this is actually what Wix did 3 years ago. We had a website, but they dropped the mobile. We had lots of web developers, and Wix management thought, okay, now we need to recruit lots of Android developers and lots of iOS developers. It's not scalable, so they decided just not develop mobile. And I'm sure you're familiar with this approach in startups that's saying, let's do first iOS or let's do first Android. And this is not something that we want to do. And the third one is the quality. Companies compromise on the quality. They can pick, for example, web view-based solutions such as Ionic or Cordova or any other web view solution. And we know that the result is not good as native application because these solutions trying to mimic, to simulate native views. And users know how to differentiate this. So all these approaches are not good for us. Let's see what React Native promises us. React Native enables us to build a mobile application with JavaScript and React, targeting different platforms, iOS, Android, Windows, whatever, but using the native building blocks of this platform. Meaning we can build a native application using JavaScript. And Wix, as a web-oriented company with lots of web developers, it sounds very good for us. Let's try to understand, remind ourselves, I'm sure you all know, what does it mean React Native? React Native is, first of all, it's a framework. It consists of two main layers. First layer written in native code, Java or Objective-C and Objective-C. The Java part can talk with the Android SDK. The Objective-C part can communicate with the iOS SDK. And both of these codes wrapped with JavaScript code and exposing to the React Native developer a unified API. Okay, I will use this. A unified API. So our code, our business logic is written here, and we are using this framework. In addition, we can extend React Native because React Native out of the box do not cover all the native capabilities. So we have to extend React Native with libraries, meaning we can implement small functionality in iOS, in Java, wrap it with JavaScript, and we have a library, infrastructure library. Sounds good. Let's see how it worked. How it works on runtime. So our native code compiled to binary file like regular native application. Our JavaScript code, our business logic, bundled with Metro bundle to a huge JavaScript bundle. Usually it's one file. We can do it several files. Depends. Both of these outputs insert into the APK in case of Android, in IPA files in case of iOS. And during runtime, the binary native side running as native application, as regular native code, and the JavaScript code executed using the JavaScript virtual machine that communicate with the native code through the bridge. The bridge is written with C++ and C on the low level. Sounds great. How we benefit from React Native? So first of all, we really can share code, the business logic between iOS and Android, and sometimes also with the web, if it's some closed SDK or something. In addition, we can reuse resources. We can take people from web and easily make them write to mobile, and after that return them to the web. It's very easy. Our development cycles are shorter than in native because we can use hot reload. We just need to update the JavaScript. In native, we need to compile the native code, and usually it takes time. Another thing, the fact that our business logic written in JavaScript, we can use this fact to ship our changes, our business logic directly to the users. Just update the JavaScript without updating the native code of the users. We can use solution like Code Push or others, or build ourselves some similar solution. But the most important thing is that our teams are now product-oriented teams and not platform-aware teams. So the developers focusing on the product and not on the platform. But also, this comes with a price, because React Native, it's not perfect. It's a new framework. A new framework, it's only in version 0.59, and it has few bugs. There are monthly updates. React Native React Native team releases an update almost every month, and they have breaking changes, and we need to adjust our code to work with the new React Native version. And there is no enough development experience with React Native, meaning there are no enough big companies that are in production with React Native for a long time, comparing to native. For example, we don't have lots of profiling tools for React Native to measure the memory consumption of the application compared to application in Android or in iOS. And of course, performance. We all know that the performance of React Native is not perfect. For example, the start time of the application. When the application starts within React Native, first the native code is initiated. After that, all the native modules need to run. After that, we initiate the JavaScript core engine, and then we need to load all the JavaScript code inside this engine. All this takes time. And we always see in the React Native application a splash screen or a white screen. And if you think, for example, native application or native good application, for example, let's take WhatsApp or Telegram, it's almost immediate. You see only a really, really short blink of white screen. And this is the difference. And this is, of course, a downside. In addition, we have architecture bottlenecks. JavaScript is single-threaded, and we have the bridge. So the bridge becoming also a bottleneck because we need to process the messages coming on the bridge, and the JavaScript is single-threaded, so it's a problem. And of course, it's incomplete. React Native, as I said, do not cover all the native APIs, and then we need to rely on third parties, open source, and libraries. And this is a problem. Any dependency of your code, if you depend on some other third-party code, it's a problem. But at Wix, we decided that this price is good enough for us, and we will attack this downside and think about them as challenges and try to resolve them. So we are trying to create a lots of development tools to profile our application. We are trying to fix the startup time, and we are trying to build a lots of libraries to complete React Native, the missing parts. So now that we decided that we are going to work with React Native and it really fits the nature of our company because we have a lot of web developers, we need to pick the right architecture. And the right architecture, almost for any software project, is modular. What does it mean, a modularity in software? It means that every developer is independent, meaning he can develop without being blocked by other developers. He's working on closed scope product, and he don't need other people, something like that. The same with deployment. Every developer should be able to deploy his changes without being dependent on other teams or on other developers. The same for testing. Every model should be tested in the isolated environment, meaning the model during the test should not be affected by other models or by any other code. And usually, modularity reflects the structure of the company. There is something called a Conway law that, in simple words, meaning that the design of a system reflects the structure of a company. And otherwise, the structure of the company reflects the design. And I'm sure if you think about your project and your companies, you will see that it's very similar, the architecture of your product to the structure of your company. And if it's not, meaning you need to change something, the structure of your company, of your teams, or the architecture or the design of the product. So Wix as a company is already split to some sub-companies, for like stores, booking, events, media. And each sub-company is focusing on features related to some product. For example, stores working only on features related to stores, online stores. For example, catalogs, card, payments, stuff that online stores need. And in each of these companies, we have a server team, we have a web team, and we have a mobile team. The same for QA, the same for product, and for all the rest of the employees. And each company is fully independent. There is a R&D manager, CEO, like a small startup. In addition, we have an entity called the guild. The guild unified all the developers professionally. So we have the server guild, we have web guild, we have mobile guild. So when we thought about an architecture for our mobile applications, it's supposed to reflect this structure in our case. So let's see how we did this. We defined 3 entities. First of them is the engine. The engine is the core of the application. It consists of native code, and it knows how to load a model. In a few seconds, we'll understand what is a model, and provide this model all the native dependencies this model needs. A model is independent encapsulated business logic. It's written only in JavaScript, and actually it's a code that consists of a business logic that describing a certain product. And of course we have libraries that they are just an infrastructure, like React Native navigation. Their part is to answer some infra problem. You can think about this as For example, Chrome and extension. Chrome know how to load extension. Extensions don't know anything about the other extensions. And Chrome actually don't care about the extension. It just know how to load them and maybe provide them some API. And it's also very similar to Expo. When you work with Expo, you download only the native code in your application, and then you develop only the JavaScript and inject it to the Expo app. So our structure is a mix of both of these ideas. Let's see how it works. So we have the engine, as we said, it will bring as a dependency all the native dependencies and also some JavaScript dependencies that we would like that only one version of this library will be in our project. For example, we don't want many versions of Lodash from some reason, because if every developer will bring its own version of Lodash, we will have a lots of Lodashes in the final JavaScript bundle, and it's a lot of JavaScript, and it will take time to load this on the startup. So there are some libraries that we prefer that will be one version of them. And there is a model that engine can load this model, and this model can bring any other JavaScript dependency that he wants, that he needs. And in such way, we can load a lot of models, and the engine knows how to load these models according to certain configuration that he can read. Which models to load, in which order, and some other configurations that are less interesting. Let's see an example for a library. For example, we have react-native-ui-lib library. It's a library containing all the UI components that our application using. Why do we need this library? First of all, it's increasing development velocity. We don't want that every developer in every team will struggle to develop UI components. We have an expert team doing that. The second reason is the quality of the application. We don't want two teams to develop their two different buttons. We want internal consistency, that all the buttons in the application will look the same with the same UI guidelines. So we have special teams that are responsible for this library. And this is, of course, open source, because there is no Wix business logic inside this library. And we have lots of open source libraries, most of them infra libraries, like React Native Navigation, Detox, our testing framework, Interactable is a gesture engine, React Native Calendar, and lots of them. You are welcome to go to the Wix GitHub and see them. Let's go over the three entities. So the engine contains, as I said, from the native code, and we will have an Android and iOS library. In addition, it has really, really little JavaScript logic for some business logic. And we have a package.json that will contain all the native dependencies, all the libraries as a dependency. In addition, when we build the engine on our CI, it will build the native code and will generate an APK and app file. App is like APK. And this is actually all our native code, the executable of our application. And in that way, our developers can work only on the JavaScript, and then with the bundler, with the Metro bundler, put their JavaScript code inside this APK and execute their code. So actually, our developers don't need to work with Android Studio. They don't need to work with Xcode, and they don't need to wait until their native code is compiled. And this is really, really cool. And increasing our development velocity and development experience. There is less flakiness because builds are not broken. A module, we see that we don't have a native code because it's only JavaScript, it's only business logic. So it's have source library and image library with assets. So also has test library with few tests. And it's supposed to implement a file called module.js, and this is actually a contract between a module and the engine. And they can implement some methods that are describing the engine about their functionality. For example, a model can describe which of his methods are exposed to other models. And other models, if they want to call this method, they will do it through the engine. Next, we have Wix App Repo. It's really small repo with CI scripts and a package.json that will list all our models and the engine. It will connect everything together. And as you see, all the models and also the engine is tagged with a special tag GA, general availability. And the meaning of this tag is that this version is stable. The version of this model, for example, awesome model, in GA version, it's the stable version of this model. So now that we have a good architecture that reflects the structure of our company and fits our needs, let's look on the development process of a model. So as we said, the engine brings all the libraries, and a developer during his work don't need other models. We don't want him to be dependent on other models, because other models maybe they have bugs, and we don't want them to crash our application during our work. So each developer will work on his own model and the engine, and he will tell the engine, load only this model. Let's see how it really works. So a developer thinking about his code, he's coding, he's doing commits. After that, he's pushing his code to the GitHub. This will trigger a build on the TeamCity. We're using TeamCity as a CI server, and this server will build this model. We'll execute some tests. We'll talk a bit later about testing, and we'll publish a new version to the npm repository. And this will happen again and again until the developer decide that he finished his feature or he decided to release a version. So then he will tag his model, his best version from all the version he did, with tag called RC, release candidate. And this will generate a package.json with this configuration. All the models are GA'd except the new model, the awesome model now is RC. So in our application, we will have all the models in the stable state and only our new model with unknown state with some changes. So now this will be also built on the TeamCity, but now we're building the full application. And the result is a Wix orange application. Orange application in Wix meaning it's internal application, it's not going to production. And we publish it on Hockey App. Hockey App is a system for internal distribution of binary file of applications. And then the developer and also the product or the QA can work with this application and with the new feature developed in the awesome model and test it and decide if it's good enough or not. Let's say our product said, okay, it's great, let's release it to our users. Let's see how we do this. So all the developer need to do is just to tag his model, his best version, with GA, general availability. And this will trigger a build with all the models and the engine tagged with GA, meaning all our models and the engine are in stable state. This will create a purple application, and this is the production application. and it will be published to Hockey App again for internal distribution, and also Google Console and iTunes Connect as a step before publishing it to the world. Next, our QA team will do a quick manual sanity, and if they decide it's good enough, they will publish it to the stores. Of course, there is a step here that the release manager needs to approve the version if it's fit the business needs. Maybe we cannot release now a new version because, I don't know, there is a Christmas or something and we don't want to add new features. So we can see that the development process and the deployment process is fully independent from the point of view of a developer. The only thing that blocks him is the QA and bugs and the release manager, the business decision of the company. Of course, if we want to change the native code, we need to change the engine. In that case, we are releasing once in 2 weeks an engine version containing all the changes in the native and also all the updates that we want to do in our libraries. And then in that case, we will do a full regression by QA because it's changes in the infrastructure and it's going to affect everything. So we have to do a full regression. Let's talk a bit about infrastructure, because we need, for supporting all this process, we need a good and stable infrastructure. And we'll start from testing. And of course, we have a pyramid. We will not dive very deeply into testing. We will have a talk in the next meetup about the testing infrastructure in Wix, about our testing solution, the Detox. But the idea is like that. For each module, most of the code is covered with unit test because it's very easy to maintain, it's fast to execute, and it's isolated. Everything that we cannot cover with unit test or some happy flows, we will cover with mocked end-to-end test with Detox. Detox is our solution for automation test, and it actually runs a simulator or emulator for Android and clicks on buttons and doing some flow. And in the end, in the top of the pyramid, we will execute end-to-end tests covering cross-modules flows. For example, user logged in, went to store module, did something there, after that went to some other module and did something there. And of course, as we go up in the pyramid, the tests are more flakeable, they are more dependent on other system parts. For example, the end-to-end test, production test, will depend on a server, on network, on the machine we're running on, and they are harder to maintain. So we really try to keep here as less as possible tests. Let's see how Detox works. Just an example. You can go here. There is really good talk in YouTube about Detox, explaining how it works, and the repo is there with great README and really easy to integrate. And you can see here how it really clicks on the buttons, and this is actually what is running on all our build machines. Yeah. So let's go over the infrastructure tools that we are using at Wix. So for CI servers, we are using TeamCity. For build machines, we are using macOS because we are building for iOS, of course. And we are using VMware for virtualizations because we want several builds run at the same time on a single machine. For publishing, we are using NPM and Hockey App, as we said. For reporting, for example, when the build is finished or if the build is failed, we are using Slack because it's convenient, everyone using Slack. For testing, we are using our own solution, the Detox, as I said. And for the signing and deployment, we are using a Fastlane. Fastlane, we talked about it on our first meetup. And of course, just a second, yeah. And of course, for maintaining a good quality application and React for users' bugs and the issues, we need to monitor our production. So we need to track our errors. In React Native, we have two types of errors. We have JavaScript errors, the business logic, and we have native code errors, crashes. And if we want to make it scalable, we need to make sure that for each issue, it's very understandable and very clear who is the owner of this issue. And for JavaScript, we're using Sentry for now. And currently with Sentry, we have problems to identify from which model the error is triggered. So we're thinking to move to Bugsnag and Crashlytic, or Crashlytic. Crashlytic actually today announced that they are supporting React Native with full stack traces, cross-platform stack traces. And for native, we're using New Relic to monitor our network and native crashes. We're also using Upsy. Upsy is a monitoring tool that can record the usage of the users. And currently there is problem to use it in Apple. And we're also using the native tools, the iTunes Connect. There are great crash monitoring there and the developer console. So to recap the story, to maintain a scalable mobile development and decide the right architecture, we first need to use the right framework that will suit our need, the nature of the company, the nature of the developers, what developers we have in the company. We need to stick to modular architecture. We need to make sure we have independent development process. We need to make sure that we have independent deployment process, and we need a good infrastructure to support all this stuff. What does it mean, good infrastructure? It's meaning a good and stable CI and automated tests. We cannot rely on manual testing and in scalable work, because manual testing, it's not scalable. For example, we have lots of versions in production. We have lots of different devices. And of course, monitoring of our production to be able to react quickly to issues in production. And the today's status of Wix team and Wix application, we are one of the biggest React Native project in the world. We are 71 developers writing the same in one application. It's amazing. It's one of the biggest mobile project, I think. Part of us coming from native background, part of us coming from JavaScript background. We are able to share more than 80% of our code between iOS and Android, and we can share some of our code with the web teams, and it's also amazing. And the most cool stuff is that we are able to release a new version every day, and every developer from the 71 developers is able to decide that he wants to release a version today and make it happen. So this is our status today.